a crack in the ground caused by an earthquake in Japan. If this new idea is correct, 2018 should see up to 30 earthquakes of magnitude 7.0 or greater. Image credit Cartori C. Wikimedia Commons. A new story based on a fascinating scientific paper is making headlines all over the news. The slowing rotation of the Earth may be causing synchronized earthquakes. Moreover, as the Earth's rotation has been experiencing this exact type of slowdown, we may be due for this exact uptick in earthquakes just next year. While media coverage, as always, is breathless, there are a number of more sober takes saying that we might not have more earthquakes next year after all. The important thing to take away is that we have had periods over the last century where greater numbers of more powerful earthquakes have occurred. There is a relationship between these periods and the slowing rotation of the Earth, and we've been going through another period of slowing rotation. Will there be more earthquakes next year? And if so, why? Let's look at the science to find out. The layers of Earth's interior are well defined and understood thanks to seismology and other geophysical observations. But how the changes to the Earth's interior affect our surface are still not fully understood. Image credit Wikimedia Commons user Suachi. We think of the Earth as a spheroidal planet that doesn't change with time, but that's not exactly true. Inside our planet, we have multiple layers: the crust, the mantle, the liquid outer core, and the solid inner core. The inner core hasn't always been there, but formed relatively recently in geological terms, between 1 and 1.5 billion years ago, as the Earth has cooled. Deep inside the inner core, three big changes happen over time. Long-lived radioactive elements like uranium and thorium decay, releasing large amounts of energy in the form of heat. Gravitational contraction occurs, causing the core to release energy and slowly morph into a more stable, denser configuration. And the outer core at the boundary of the inner core slowly solidifies over time, where we expect that small, frozen sediments build up on the edge of the inner core over time. In other words, the inner core is growing, becoming more dense and stable, and changing its arrangement. A depiction of Earth's interior showing the movement of molten rock which makes up the mantle. Image credit Getty Images. These small effects add up to have a big change on the Earth, increasing the density of the core, particularly during rearrangement events, brings more of the Earth's mass closer to the center. Outside of the inner core, the liquid, metallic outer core spins around, creating Earth's magnetic field. As the outer core shrinks and the inner core grows, small but substantial changes occur in Earth's magnetic field, which eventually propagates to the mantle, and then the crust. Tensions in the mantle and crust grow and grow. They eventually break, which causes a planet-wide mass rearrangement, an earthquake, and a brief rise in Earth's rotational speed. Tidal rhythms, such as the Touchet formation shown here, can allow us to determine what the rate of Earth's rotation was in the past. During the time of the dinosaurs, our day was only 22.5 hours, not 24. Image credit Wikimedia Commons user William Borg. Under normal circumstances, the changes in the core are small, and even though the Earth's rotation changes over time, it's the effects of the magnetic field that are more important for surface-level earthquakes. The Earth has many layers, and internal changes take significant amounts of time to propagate to the surface. If internal rearrangements have been happening in the inner core causing magnetic field changes in the outer core, is it reasonable to expect that a few years later, we'll begin experiencing a slew of powerful earthquakes here on our crust? When we examine when the most powerful earthquakes of all have struck, there appears to be no pattern. It's essentially random. But if you look at how frequently earthquakes that are quite powerful, say magnitude 7.0 or above, have occurred, you normally get between 15 to 20 of them in a given year. However, some years are significantly worse than average, having about an extra 10 powerful earthquakes above the average. If you look at the worse-than-average years, they appear to be periodic every 32 years or so. As geologist Trevor Nace noted, the team was puzzled as to the root cause of this cyclicity in earthquake rate. They compared it with a number of global historical datasets and found only one that showed a strong correlation with the uptick in earthquakes. That correlation was to the slowing down of Earth's rotation. Specifically, the team noted that around every 25 to 30 years Earth's rotation began to slow down, and that slowdown happened just before the uptick in earthquakes. The slowing rotation historically has lasted for 5 years, with the last year triggering an increase in earthquakes. A picture taken on November 15, 2017 shows Cook Village near to Sabal's Ahib, 2 days after a 7.3 magnitude earthquake struck Iran's western Kermanshah province near the border with Iraq. If this new theory is correct, we can expect many magnitude 7.0 quakes in 2018. Image credit at Getty Getty Images. This slowdown was observed in 2014, 2015, 2016, and now 2017. If 2018 is the fifth year of the slowdown, and if this pattern holds, we'll expect 2018 to be a year rife with a large number of significant earthquakes. If this hypothesis is correct, it would herald a momentous advance in the field of geology and geophysics, as the ability to predict earthquakes in any important way has eluded us for a very long time. However, there are many reasons to be skeptical. The connection between the changes in the magnetic field and Earth's periodic slowing down appears to be correlative, but no causal link has been established. We are not certain that this mechanism is real. We've also only had approximately 4 years since 1900 that display this excess of earthquakes, and to predict that 2018 will be the fifth requires a rather large leap of faith. Finally, 2017 has only exhibited 7 earthquakes of magnitude 7.0 or higher, well below the 15 to 20 average. Statistical fluctuations are large, and even if we get 25 to 30 earthquakes next year, that doesn't necessarily mean that the Earth's slowing rotation caused it. A map showing the locations of earthquakes above magnitude 6 over the last 100 years. Image credit David Bressan GIS. Over long enough times, the Moon is the only dominant factor in slowing down the spinning Earth, as our 24-hour day is relatively recent, and won't be around forever. But the fact remains that we do have years that are more dangerous for earthquakes than others, and we don't have either a good explanation as to why, or a good way to predict when those years will occur. If this new study is correct, not only will we have taken a giant leap towards doing both, but we'll have some substantial evidence to support this theory just 12 months from now. It's a tremendously exciting time for science.